Okay, so in this video we're going to focus on making this ring base here. So we are going to take care of the OD, the ID, and the angled holes and the chamfer in this video. The other portions I consider optional, these tapped holes here and this feature. So we're going to take care of the most important features to make sure this functions. So let's get into Mastercam. We'll create our OD here. Go to wireframe, circle, and it should be a 3 1/4 outside. Get back into the drawing here, and it looks like a 2 5/16 ID. So we'll go back into Mastercam and take care of that. All right, and there's essentially the 2D geometry what we're looking at. Now it's time to go into solids and extrude this shape. And this part overall is 5/8 of an inch thick. So we will change direction and change the distance to 0.625. Okay. So looking at the drawing, next thing we'll take care of is going to be this chamfer. Back into Mastercam, we'll do chamfer 1 distance. It's a 1/16 chamfer, so I'm just going to pick this edge here and selection, and the distance is 0.0625. All right, we'll hit green check. There is the basics of this model. Okay, so for right now I'm just going to take care of the levels. This level is going to be part wireframe. Then I'm going to do a new level, and this will be model. All right, and I'll take the actual solid model and put that on level 2. All right, good time to save. I'm just going to save this on my desktop as 5-axis drilling. All right, and what I'll do is I'll transition here, let you guys catch up, and we'll take care of these 13-degree angled holes. Okay, so let's take care of the angled holes here. So we'll take care of a bolt hole circle at a diameter of 2 inches, 860 thousandths into wireframe, and I'm going to make sure my levels, the part wireframe is active. I will then draw the arc, diameter of 2.86. and then hit green check. And then what I want to do is I'm just going to draw a quick line from 0, 0 out into space. The only thing I got to watch out for is that it is horizontal. So, and that is not super fussy, but it is best. So if like I go to top view here, you'll get the perpendicular icon right there, and click here. And then I just hit divide to ensure that there is a nice crisp intersection where I want it. I hit circle center point, put at the end of the line, and these are 1/8 of an inch diameter circles or holes. Then what I do is I delete this line. Now what I want to do is tip this wireframe geometry. So to do that, I'm going to go to transform, dynamic, select this hole and hit end selection. Place the dynamic gnomon right in the center. About the Y, we're going to tip this -13 degrees, just like that, and we'll hit green check. So now we have a tipped piece of geometry. All right. Now I'm going to clear colors, and I'm going to go to rotate this arc, okay, and notice it defaulted to 3 instances, 1, 2, 3, at 90 degrees in between. That is correct, that's what we want. Copy is on, green check. Right click, clear colors, and you'll see our geometry. Now it's time to cut the holes into the solid model. So we'll go to solids, extrude, select the 4 circles, hit green check, and we are going to end up doing a cut. We're going to go both directions to make sure it cleans up. And these holes, if you look at the drawing, okay, I don't see any specs on the depth here. We're going to go about 1/2 an inch. So if we go back into Mastercam, we do a depth of 0.5, and then we go into transparent view down in the right corner of the software. We can see the holes. We'll see that we are not breaking through the edge. Okay, that should work for us without any problems. So we'll hit green check now, and we have our angled holes. Okay, if I turn the wireframe geometry off, we'll see our workpiece. Okay, so there's the angled holes. This part, there's the the actual workpiece is complete. I'll put a transition in here. We'll draw our stock, we'll merge in our fixturing, and then we'll start the machining process. Okay, so let's take care of our stock. If we go back into wireframe, and I'm just going to turn, that one off. I'll do a new level, and this will be stock. And we'll end up drawing just a circle on the top here. And the OD, the stock we're using, is going to be 4 3/8. All right. And then we'll hit green check. And then what we'll do is we'll extrude this down. Now, this stock, we are going to be holding in a 3-jaw chuck on the UMC. The distance we're going to hang on to, the jaw step is 3/8. This workpiece is 5/8. So if we hang on to, even 1.5 inches, we'll be fine. Make sure it's crate body in one direction. So again, see how that doesn't take care of everything? We got to hang on to enough that gives us clearance away from the jaws. So even if we go, 1 inch, we should be okay. But let's go 1.25. See how that looks. And then let's take a look at this in transparent. That should be enough to hang on to. We will, obviously we'll bring in the stock, bring in the chuck geometry. We'll merge that in right now and see how that looks. But that's what we're going to work with for now. I think that'll be fine. One thing I will do is I will highlight this, click that, and I will change the stock color to red. Okay. Good time to save. And now what I'll do is I'll go to File, Merge. And I'm going to take a look for where I have the UMC tooling right here. There we are. Okay. So I'm going to move this somewhere here for right now. Okay. I'm just going to hit green check and clear colors and out of here. So what I want to do is, this is our fixturing. Okay. This is going to be the workpiece. Now, again, I don't really draw the chuck jaws. I treat this whole thing as stay away, if that makes sense. So what I want to do is, I know that the step I want to be on in the jaws when I flip the jaws on the UMC are 3/8, roughly 3/8 deep. So what I'm going to do is, there's a couple things here. This is the base of the chuck. Okay, we can position this down 3/8, or I can take a piece of geometry. If I go one edge only, and actually I want to make sure I'm the right level here. This I want to move, so let's put this on a new level. This will be level 4. And this will be fixture. And make sure that level is active. And what I want to do is, I'm just going to do curve on one edge. And then I'm going to go into Transform Dynamic, select that curve, hit End Selection, center it, and bring this down minus 0.375. All right. That's good. All right, that'll help us reference this. Now what I want to do is, I'm going to position the entire workpiece, or I'm going to move the fixture to the workpiece, and I'm going to go to Dynamic. You could select this arc, but I'm going to go right from the top here for right now. Bring the Z up to the bottom of this workpiece, just like that. Okay. So we know we're on the bottom. And what I usually do is, then I'll bring the Z up. Now see how it doesn't really change? If we go to the bottom here, I just hit apply, and then reselect everything. So like, all your fixturing, hit end selection. And even, I made a mistake there. You got to make sure you select everything. So even, there's a couple options here for selection. If I just go clear colors, and what I would normally do is just select everything, just being kind of careful with the window, and you should not get anything above it. It should select everything down here. And since there's no 2D geometry in the bottom of the part, we should be good to go. Then if we go to dynamic, select the top here, and then come up 0.375. And then hit green check. And then if we go to transparent, we should be in the front view right in line with that arc. So that'll work for us. That's a good representation of what's going on. You'll see we have plenty of room to hang on to this. Okay. That should be fine. The plan for this workpiece, there's a couple ways we could hang on to this to actually part it off. You can use a slitting saw. I don't think it's going to be worth it for this example. The other option is we could actually grab this in soft jaws, flip it, and mill it down. What we'll probably end up doing, just to give people more experience on the wire, is grabbing this from this side of the workpiece, maybe on the ID, or even the OD in a chuck, in a 5C indexer in the wire, and then we'll part it off that way. That's what I'm kind of thinking we'll do there. And that's not the most efficient way. That's just to get people more experience on the wire when we get there. Plus, it runs on its own, so once this is running, you can go do something else. We only have to make 2 of these, so it's not a big deal. So we'll live with that. This is all ready to roll and position. Good time to save. And then if I go to, I gotta go back and go to planes, and I'm just gonna change these like that. Go to top view. We'll be able to use our top view for this gnomon, but I think it's easier to create a new gnomon at the top and leave the top at the bottom. I think that helps with positioning it on the machine table when getting into simulation. So what I'm gonna end up doing is just selecting everything. And then I'm just going to go to dynamic, and I'm going to select the bottom, bring it up in the Z. And see, I didn't get everything, so you got to be very careful with that. And then dynamic, select the bottom, bring it up in the Z to the gnomon. Looks good. Hit green check. And then I'm going to do a new one. It's going to be dynamic is fine. From the center of the stock or the workpiece is fine, and this will be G54. We will make sure to manually call it 0 so it forces G54, and we'll name it or set it as our WCST plane and C plane and hit green check. So there we are there. Our top will be on the bottom. There it is. So now we're pretty much ready to machine this. I will save. I will clear colors. Okay. And I will go into toolpaths and bring up my UMC that I want to use, which is going to be the Haas UMC 750SS post right here. Okay, so good time to save and a good time to put a transition in, let you catch up, and then we'll start with the simple toolpaths, just milling this to size, take care of, we won't be doing any 5-axis work for this first operation. It's just 3-axis work. Okay, so I'm going to do a stock model for this one. So this first toolpath group will be stock model. And I'll go to the stock model settings, and I'm just going to go, the initial stock shape from the stock itself. So I'll get into here, and just to be real clear with my levels, I'll turn the other options off. And select it, or just window it. Usually click 3 times or you can window it. And then end selection. And that's good. There are no source operations. Everything here is fine. The color's fine. This will be stock. And the stock plane, let's go to top and hit green check. And it should look just like what we have. So that's good. So I'm going to turn that one off. And we'll do a new toolpath group now. And this will be operation 1. And let's take care of roughing this out. So I'm going to turn the fixture back on and the part model on for this. And we'll end up using, we could use this 2D geometry if we want to. So in toolpaths, let's do a dynamic toolpath. And the machining region is going to be here. And we're going to go from outside, and the avoidance region is going to be this outside. And hit green check. I'm going to preview the chains. Looks good. Okay. One thing I will do is go transparent. And actually what I'll do here also go to levels. And I want to turn the stock off just to make sure that lines up. And we are seeing the chamfer, but I just want to go to top view now and double check that. Looks good. So we'll hit green check. And the tool we'll use can be a 1/2-inch end mill. So go to here, go to the filter, and we'll just select a 1/2-inch end mill. That's fine. This will be tool 1 for us. This tool, I'll double check the settings here, finalize properties. This will be a carbide cutter. We'll hit finish, reinitialize the speeds and feeds. One thing I need to double check here is I'll just green check that out. Get into properties and go into tool settings, and I'm going to go from material, and this material we're going to use is going to be 6061 aluminum from the mill library. That's fine. If we edit this, again, it's on the slow side, like I say in every one of my videos, but we're okay for right now. We'll hit green check. That'll get us in the ballpark. Go to parameters again, reinitialize. This should update. That's still super slow. I'm going to turn RCTF on for this. I'm going to end up going to a surface footage of around 800. And then a chip load of this cutter of 3,000. And that's still conservative, but that's in the, in the right direction of what we want to do. This will be roughing OD. And the holder I'm not worried about for this op, so we'll ignore that. The cut parameters, we'll go to a step over. 25% is fine. We'll leave 5,000 on the walls and nothing on the floors. The back feed rate will be 500. Everything else there is probably okay. No depth of cuts. Entry motion is going to be plunge only. Linking parameters. Now, I want to be incremental for all of this. And the clearance be 2.0. Everything else is okay. The depth, this should be 5/8. But I'm going to go a little deeper than that into the stock. We should be able to stay away. Again, remember the stock is hanging up a little bit. So let's go like 750. And I'm going to regenerate that. And again, we are still above, but we're not hitting the jaw, so that'll work out. Let's see what else we have here for some settings. The arc filtering, I'll turn the line arc filtering on. I'll change the tolerance to 3,000ths and split it. That's good there with apply. Planes are fine. Coolant will be on. What else we have here? Should be good. 25% should be fine at those speeds and feeds. That should be okay. I'm not really, again, this is slow. Usually when I'm dynamic milling aluminum, if I am, I'm around 12,000 RPM. The feed rate's usually in the 125, 150 inches per minute range. But again, for learning, I like to keep this on the reduced side, just in case you make a programming error. But everything else should be okay, so we'll hit green check. And I'm going to end up putting the stock model on here just to see this. And we can run this now. And we can see what we have going on. Okay, pretty clean to rough that out. Let's take care of, and actually we'll rename this now, roughing op 1. Okay, and I'll separate this a little bit. So we're good with that one. Let's do a new one. So let's just copy and paste here. And this operation here will be roughing the ID. And we need to change some things in this. One of the big ones you got to change is make sure we helix in. But let's change our chaining dialogues here. The machining region, for us, we'll get rid of the avoidance. The machining region is going to be this ID. That's all we need there. This is an from inside, or stay inside, sorry, and preview chains. We go to top view. Looks good. So the tool is fine. All the speeds and feeds are okay. The cut parameters should be okay. Entry motion will go to helix only. Linking parameters is going to be the same. Arc filtering, make sure output 3D arc entry motion is on. That'll help smooth it up. Planes, everything else is okay. We'll hit green check. Okay, let's turn our stock model off here quickly. We'll see our toolpath looks good. Okay, so if we go to backplot and only backplot that operation we just created, we'll helix in and rip around. Okay, now you can tweak the helix settings. Let's say you want to slow down to helix in. Entry speeds and feeds, you can reduce this. So, that's up to you. I think you'll be okay. Again, we are not running that fast. So, again, if you do run into some chatter issues, instead of changing it up there during the, especially in like stainless or something, I will use these, and I usually reduce like 50%. Let it work its way in. I'll put a little dwell on depending on how quickly the spindle needs to spool up to make sure a spindle's at full RPM before it starts moving. But that's optional. I think you'll be okay. The plunge angle at 2 degrees is probably okay, but we'll change to 1 just to be safe. Z clearance 1/8 of an inch is fine. Everything else is okay, so we'll hit green check, and we'll consider that done. Okay. And good time to save. So after this, what I'll do is I'll transition now. We'll take care of our finishing. So right now, I'll just reinitialize our stock model while we're at it. I'll right click, new toolpath group, and this will be finishing operation 1. Okay. And one thing I did forget, I will put a facing operation in. You don't need to see that. I'll probably do that first. I'll put it right here. I'll do a quick facing operation just to face to 0. And that's not a big deal. You should be able to do that by now. So I'll put a face to 0 in here. I'll come back. We'll do the contour toolpath together, and then we'll take care of the 5-axis work on this workpiece. We'll chamfer it last. We'll do a model chamfer on the inside, and that'll be it for this video. I'll take care of the the parting off. You should be able to do. Again, I'll leave that up to you how you want to do that. So I'm sure by now you'll be able to program that. So I'll transition here, and we'll continue. All right, you can see I added the facing operation here quickly. So we're done with the roughing for now. What I need to do is get into some finish operations. So I am going to get into my planes, and I'm going to end up turning, levels, and turn my stock off. And let's get into some rough, I just want to be able to comp these aside, get a nice finish on them. So go to contour, and I'm going to select the outside. And tool, we'll use the same tool, I'm not worried about it. Surface footage, feed rate's fine. P finish OD. Cut parameters, wear compensation, no depth of cuts, lead in, lead out. We will make sure there's an overlap of like 30 thousandths. Linking parameters, the depth will be down there, and actually it's going to be minus 750. Everything else incremental. Make sure you put the clearance on and hit green check. And there's our finish pass. We'll copy and paste this, and then what we'll do is we'll update the chain. So we'll rechain all. We'll select this chain and hit green check. And we generate the op, and that should work out just fine for us. I will rename this finish ID. Okay. So that's good. Okay. And now it's probably not a bad time. I know I said I do the chamfers last. Let's just get it out of the way now. This one is a 16th chamfer, and I do have 1/8 inch chamfer mills in the shop. So even if that, we'll use that cutter. It may not be a full 16th because I don't want it to gouge, but that's what we're going to use. So we'll use whatever. This is just for cosmetics, so we'll put it in there. Let's right click and let's do groups, new toolpath group, and this will be model or chamfer / deburr. Okay. All right, let's take care of this model, this chamfer toolpath. It's not a model chamfer, but we'll take this upper contour, right click, copy, and paste it because the chain geometry is going to be very similar. I'm going to get back into here. I should have a tool loaded, but if not, it's just going to be whatever tool you created, your 1/8 inch mill drill. I know it's not going to be able to create the 16th chamfer, but that's the chamfer tool we're going to use because I know I have a lot of them in the shop. So we'll leave that there. Speeds and feeds are okay. We might have to reduce that a little bit. Surface footage is going to be like 800. And we'll reduce that because the machines don't have that. So let's go maybe, I don't know, 500. No, still not. Let's see here. Yeah, that'll work. I didn't reinitialize. That's my fault. And we'll do a 1,000 chip load. That'll be good for this small cutter. So we'll hit apply. In the cut parameters, we have to go into wear is fine, but we're going to go to a 2D chamfer. The chamfer width we're going to select is 40 thousandths. The bottom offset will be roughly 10 thousandths. Okay, and that'll give us a decent chamfer. We can even go like 45. It should be okay. Leading and lead out's fine. Linking parameters, the depth we need to change. That really needs to be incremental. So if we just go there, it should be fine. Everything else should be okay. We'll hit green check and take a look at what we got. So this is not going to actually touch the workpiece. So even in backplot, if we go, single block through this, you'll see that we are away here, which is fine, but we are doing much less of a chamfer. But that's okay because I'm not really worried about it. I just want to make sure that we actually have chamfer mills available. So that's good for this one. The next one we need to do is we have model chamfer, and that's just going to be deburr this inside. Okay, so to do that, we'll go into here and we'll go to model chamfer. I'm going to check this chain here, and the tool will be our mill drill, and we'll do we're taking a very light cut on this, so that is going to be okay. I will cut the feed down, but that'll be okay. Cut parameters, we'll do computer comp is fine. The chamfer width would be like 15 thousandths. The bottom offset will still be 10. Depth of cuts, no. Lead in, lead out, I do want to overlap a little bit. Everything else is okay. Clearance will go 2.0. So we should be in good shape. We'll hit green check. And there's our model chamfer. All right, so it's a good time to save. And that's the end of Operation 1. So go into your simulator settings, make sure everything's set up. And then I'm going to select everything and go into verify. And let's watch this run. I got the performance precision kind of in the middle. Slowed it right down. You'll see the facing operation. And we'll take care of the OD. Take care of the ID. And we'll finish everything up. And then we'll take care of our outside chamfer. Looks okay. Take care of the slight inside chamfer for deburring purposes. Looks good. That's the end of the operation. Again, good time to save. All right. And we'll put a transition here. And we'll do I'll just do right click right now, do a new toolpath group. And this will be holes 5x. Okay. So I'll turn these operations off. We'll go into hole 5x and we'll take care of drilling these 4 holes, tilting the B and C around. Okay, so let's drill these holes. We'll go to drill. And I'm going to select the surfaces of the holes. That is very important because that gives you the vector direction, which will help align the B and C axes for this toolpath. So make sure you select the surfaces. And then hit green check. Now, we're going to spot face this, spot drill it, and ream it. Just for some practice. So we'll go to tool. We'll select an 1/8 inch tool. Speeds and feeds are fine for this. This will be spot drill. Okay. And no holder information is necessary to me for this operation because we're not tipping that much. If it's up to you, and again, I'll leave it up to you what holder you pick. If you're worried about collisions, then you should put a holder in, but I'm not worried about it for this one. So we'll go to spot drills, fine. Tool axis control is where it starts changing. This will be 5-axis. No hole segments, linking parameters. We need to update this a little bit. I'm going to put calculate depth from top of line hole. The depth will be minus 0.030. No tip comp on. Everything else is okay. We'll talk about safety zone in a minute. So we'll hit green check. And hopefully the tool is not going that deep. It is not. It looks good. So you see that they are tipped. Okay. Now, we have an issue here in the fact that we need to put in linking parameters our clearance group of, let's say, 2 inches and hit green check. And that helps, but still rotation is occurring with the tool right here. That is probably okay for this low angle, but I want to show you how to kind of get it like a safe zone. So we'll go to safety zone, turn it on, and we'll define the shape by using our workpiece and selection. We'll just go to cylindrical now. We didn't have to select the workpiece. That just helps center it. We'll go to Z. And what I want to do is I'm going to increase this to something that looks okay. So that's a pretty decent clearance. So we'll go right around here. And then I'm going to offset up the zone to something like that. So this will give us a clearance zone that the tool can't go between rotations. So we'll hit green check and then hit green check again. And you'll see what happens. The rotations happen up here. So when we watch this run, it drills, goes up, moves. Now, that's not a great representation. What we really should do is go just into verify quickly. And if you watch this run in simulation, I know the tool's up in the air. I know I got to pick a different machine, but let's just watch this for right now. So it drills, goes up, then rotates. Okay? And that's the whole point of the safety zone. All right, you'll see, I don't think we need tool holder information. I'm not worried about it for this one. And that's the name of the game there. So before I get back in there, I will update my simulation settings to the Haas UMC 750. I'm not worried about the transform here. Let's verify that again in Simulate. And let's see if that's positioned correctly. It's not. It's probably 2 inches up in the air, so I'll change that in a minute. We can watch this run, and you'll see what I'm talking about. Up in the air. You want that away during B and C movements. Is it really critical? Yes and no. I think it'll give you more confidence at the machine. This is a not steep angle, so you could get away with it. But let's just leave it there for now. All right, good time to save. And we're going to be copy and pasting this operation a lot. The only thing that's going to be changing is the depths. So let's copy and paste this. And now what we're going to end up doing is taking care of the parameters, tool. Let's go to select library tool, and let's go to filter. And I'm going to go to a spot drill. Let's say 1/8 of an inch diameter is probably okay. We got to see what we have in the shop. You might end up having to use a center drill for this. Just keep that in mind. We'll just use an 1/8 inch spot drill. I'm pretty sure you could go to center drills. Let's see where we're at in here. If it doesn't come up, it's not a big deal. I forget in here if there are center drills. Right there. Radius mill, I lied to you. Nope. So we'll use a spot drill, 1/8 of an inch. So even if you use, I forget what the number center drill would have, an 1/8 inch shank, that would be equivalent. Because again, you're not going down to the 60 degree included. You're just using the 118 at the tip of the center drill. So just hit green check, and it depends on what's in the shop. Hit green check. Where to go? That's my fault. I got too random clicking here. There it is. This will be tool 4 for us. Speeds and feeds are okay. This is, a drilling operation. That's fine for us. This will be, so the spot drill, yeah, spot drill's fine. I do have to double check. I forget what I named the first one here, but this will work for us. Cut parameters. This is spot drill again. 2-axis controls, 5-axis. Everything's gonna be the same except for the linking parameters. It went 30 for the depth. We'll go 40 for this one and hit green check. Okay. So let's look at this one. That should be okay. So let's look at these two operations in verify. I'm not going to worry about the simulation for now. I just want to see what goes on here. There's the spot face. And there's the center drill. That's okay. We could go a little bit deeper. That's up to you. It depends on what tool you're going to be using at the machine. So that's enough for right now. We could tweak that later depending on what we have. So even 45, 50 thousandths, you can calculate it. Even in here, the tip of the tool. In our case, we will need to update this. So I will do that now just to make it look more realistic. The spot drill angle is going to be 118. Let's go to finish. And if we go into linking parameters, we'll end up going, the finished diameter on this tool will be like 0.90, let's say. Tip on the flat will be 0. We'll overwrite it, hit green check. And see how it went 27? That is probably not going to work out for us. We'll green check it because it was 30 before. So even if we run both of these, you'll see what happens. It's not going to be the correct depth because it's not calculating it given that spot drill. Sorry, the spot face. See? So again, into here, the depth is here. That was because we overrode it. If we get back into here and go minus, I think it was 30,000. Let me double check this first operation. Yep. So we get back into here. We're already at 30,000. If we need to create a finish number of 90, we're going to add to depth. So hit green check. There it is. So now if we select both of these, verify. Hopefully it's not going too deep. So we'll hit play. Hit play again, and that looks perfect. All right, so there's an instance where to use the add instead of overwrite. So what we can do now is right click and we can go to paste, do it again. We'll go to parameters now, go to the tool, select library tool, and now we're gonna look for the drill. Let's go a little bit under. So let's say, let me look at a tap drill chart here. And we'll go to a number 32 drill, or 116 thousandths, which should be good. So we'll go to equal to 0.116. And it will be a drill. We'll hit green check, and there it is. So we're good there. Speeds and feeds will probably be okay. I'm not worried about that. This will be tool 5. Okay. These are fine for this drill. All right. Again, it's high-speed steel. It is reduced for drilling. We'll be okay. Getting to cut parameters. This will have to be PEC drilling. So GD3 normal PEC drill. This is fine for now. 100,000. Let's change that to 50. All right. Everything else is going to be okay except for linking parameters, where now the depth is going to be right to the bottom of the hole. Okay, so right around, if you select carefully, it will highlight right there. So that works. Negative 0.5, so we'll call it negative 0.5 as the bottom of the hole, except for we will not turn tip comp on. That as far as that drill will go. Okay, so we'll make sure that our reamer goes something like 450. All right, everything else is okay. We'll hit green check. That's good. All right. Now we can copy and paste again. And we'll go to parameters. And we'll go to tool. select library tool, filter. We could add a drill, and we'll go to reamers, if I can remember where that is, right there, next to it. 2.5, green check, 1/8 inch reamer. And this will be tool 6. Speeds and feeds are really going to be okay. I will reduce the spindle speed for the reamer. I'm going to cut that to like 100. And then that's fine. Usually people will increase the feed per tooth for this. I don't think it's going to make a difference for us. This is not a real critical fit. We're probably going to end up pressing drill rod in there. So we'll leave that for now. I think that'll be okay for us. If it does chatter, we'll have to address that, but it shouldn't be an issue. A lot of people run reamers, 25% of the surface footage, but some people will increase the feed rate, and then depending on, some people will feed in, feed out, some people will feed in, not feed out. We're going to feed in and feed out. It's not a super critical fit. This is what we're going to run for this one. Cut parameters. There's different options here. I'm just going to use a G81 to do that. In and out of there, linking parameters. Here's going to be the same, except for the depth will be minus 0.450. That'll keep us 50 thou away. Shouldn't have an issue there. All right, tip comp we're not going to leave. Everything else is okay. And again, what you want to do with the reamer, that's user preference. We're just going to feed in, feed out. That should be fine for this one. I'm not going to go crazy with anything else. Some people do run boring cycles. Not necessarily like boring bar cycles, but there are cycles people use for the reamer. We're just going to use G81. I think we'll be fine with that. All right, so green check. And there's our reamer op. So let's look at all of these run. So we'll spot it. Drill it. Now see, now it's starting to drill up in space. So let's actually look at this one. Okay. So notice where it's feeding. And take a look at this. You'll see the rapiding's okay. It's the blue we got to watch. Now that's probably okay. I mean, we're not really, it is not super efficient. That's going to come into our linking parameters and into the retracts. So if we just look at this one, if we go to 0.1, right, and we look at this one retract and hit green check, and then we'll turn all of these off and only turn this one back on, you'll see the difference. So let's change all of these, okay? So if you go right here, right click, and go to edit selected operations, and we're gonna go to edit common parameters, and we're gonna change the retract to 0.1, and we'll use enable for change. Okay, so that should work. That's only gonna change the drilling operations. Let's hit apply and green check, and then we'll regenerate all the operations as it's dirty operations now. You'll see they all changed. We'll go back into here, 0.1. We'll go into the bottom one, 0.1. So that'll save us some time. All right, the clearance is up here as part of the safety parameter, so we'll leave that alone. We'll check all these, give into here, and verify these operations. Slow it down a little bit. Okay. There we go. And then the reamer. Okay, hopefully we have a little gap in the bottom there. We do. That should work fine for us. Okay, so we'll hit save here. And what we'll do, I'll put a transition here, let you catch up, and then we'll take care of the, take a look at the code and make sure everything looks okay before I say it's ready to run. Okay, so I'm going to take a look at these operations here. So just the 5-axis hole ops, and post these only. Let's take a look at what we got here. Okay, so we have our initial position, and then it gets into load up tool 3, which is our 1/8 inch flat end mill. And then it turns the spindle on, goes to B 13 degrees, locks the table, dynamic work offsets. There's tool comp. There's our Z minus number, R value, proper feed rate. Goes up to dynamic work offset off. G234 is tool center point control. That is used for simultaneous movement, very similar. So basically, you have dynamic work offset and tool center point control, and they help with the ability to use the same program at multiple spots on the machine tool. So the reason, you don't have to sync up the program to the rotary 0 point on the 5-axis machine anymore with these codes. 254, 255 is dynamic work offset on and off. That's for 3+2 machining. 234 TCPC is for the simultaneous movements, but gives you the equivalent type of the same abilities, if that makes sense. So what this is doing is it's rotating about the work offset, or it's rotating about using multiple axes at once. You'll see down here you have C and B, then you'll have X, Y, C, and B at the same time, and these are feeding at 500 in 3-degree increments, and there's a reason for that. Okay, we don't need all this code. We don't need to be that smooth in this area. I don't think we're going to gain anything, but you'll see these in every rotation. And where that comes from is in the parameters. Here is our angle step, and there's our feed rate. Let's put our angle step to 90 just on the first operation. We'll hit green check. Okay, and I'm just going to post this one op. So I'll hit G1 and a no, and then this will be 5-axis drilling. I'm just going to go -1, hit save, and let's look at this. Both of them will pop up in here. Here's -1. You'll see that it comes down, both C0, B 13 degrees. Okay, locks the table, dynamic work offset, drills a hole. Now we'll have a Z clearance, feeding at 500, going to C90, rapid, drill the next hole. Okay, you'll also notice that it changed all these purple vectors in the program. If you look at this operation, okay, it shows you the breakup of it. So we don't really need to have in our original program all of this movement like this. I don't think it's necessary. I think it's better just to have it go to the proper position. Just like this example here, you'll see that it's going, feeding C90, going to C90 from C0. Okay, here, actually, I'm sorry, I lied. It's gonna be right here. And it's going to the next, the B tilt is going to be the same. So it's going to C90 already at B13, which is what we want. The rest of the positioning is coming from the dynamic work offsets in the program itself, the X values, etc. So we don't really need all this code. So let's get rid of that for all these operations. So we'll get back into Mastercam, and you can go through here. That's what I'm going to go back and check these. So angle step is going to be 90 in our case. Feed rate's fine, green check. Parameters, angle step 90, and 500 is fine. And the last one, parameters 90. You could probably also, work with the axis of rotation, but we'll just do this. For now, this is fine. So we will look at all these. They all look the same as far as all the vectors on top here. We can look at this in backplot. And the reamer. Okay. So let's take a look at this quickly in Verify. We'll go to Simulation. And I do need to position this workpiece down 2 inches onto the table. I'm not going to worry about that for right now, but I covered that in another video, so we'll just watch this run. There's the drill op. And finally the reamer. Okay, so get out of here. Let's take a look at this code. Okay, so I do like the X-30s in G53 and Y0 around whenever there's rotation, so that's good. You don't know where you're going to be in the beginning. Brings it up, the UMC brings up 2 inches above the 0 in G53. That looks good. Unlocks the table. Make sure B is at 0, all set. Tool 3 is there. Tool 4 is going to be next in the spin or in the carousel. Spindle's on. C0, B13. Lock the table. Dynamic work offset. Position. Z position. Okay. X goes back again. It's just a kind of a duplicate code. We get back into here. We get into our drilling operation, feet of 14. Okay. G94 is the inches per minute mode. So we're good there. Cancel can cycle, come up, rotate to C90 at feet of 500. Again, the B is not moving because the B is already locked at 13 degrees. Drill. Everything looks okay. I'm not seeing anything sticking out. The nice thing is when you cancel DWO, cancel your tool height, it goes to Z 2.0 from home, X minus 30. That's excellent. But notice it does not go to B0. That's good, okay? Because we're going to be staying there anyway. There's no reason to go to B0, okay? So let's look at the other lines of code here. We're going here, 204, load up that. All the work planes, unlock the table, rotate. This is going to C360, B13. That's fine. You'll see that it keeps rotating around by 40. It'll keep spinning. It is not resetting the counters, and that's fine for what we're doing. It's just going to unwind at the end. And there are ways around that. I mean, it does go here this way. There is a code, if I remember correctly, to kind of reset the 0 so you're not waiting for it to unwind. But we'll live with it for this one. Okay. Everything looks okay. 540, 630. Everything should be okay. 500s are good for the spot drill at least. So again, the B13 tilt is okay. Inches per minute. Good. Everything looks okay here. Take a look down here. I'm mainly looking at the rotations. Okay. Dynamic work offsets on. And we continue to work through the pec drill, and that's fine. All right. 990. All right. Minus 30. And notice again, the B13 should not be changing much. It's not re-zeroing the B. That's excellent for us. Okay. And then again, it keeps on going through all these counters. And that's fine for us. We're not doing that many holes. If we were really spinning around, I would have to set this to start from 0 again or go to B0, or I'm sorry, C0 each time. I'm not worried about that for this workpiece. This is fine for us. And again, that does depend on your post processor. This particular post I'm using is newer. So if you're using an older UMC post, or your post is configured a certain way, then it might go to B0 at the end, and then or go back to B, B. It might go back to B0, or I'm sorry, not B, C0 here. It all depends on how your post is set up. Okay, so it looks good. All right, I don't see anything sticking out here that is a red flag. So X out of here. Let's watch this whole thing run. So I selected everything. Get into verify. Go to simulation. And again, I have not positioned the fixture down at the table. I'm not going to worry about it for now. We'll be okay without that. So we'll watch this run. Facing up. Rough it out. Rough the inside. Finish the outside. Finish the inside. Chamfer the outside. Should have chamfered the inside too very quickly. It did. Take care of all the drilled holes. All right, and that's it. Okay, there's our workpiece. All right. So that's about it for this one. Again, watch your post processor. Make sure you use the one that I supply. That'll definitely help out. But that's really it for this one. I'll leave it up to you on what you want to do for the next op. Again, we're going to have material hanging down here after this. It's going to look, it's going to have the material we're hanging on to. A couple options. You can wire this if you want. If you want wire experience, it'll help to get you out of the 5-axis so somebody else could use it. The other option is just flip it quick, grab it in the 3-jaw, make sure it's sitting somewhat true, and face it to size real quick while you're there. Or you can make soft jaws, or use another 3-jaw chuck on the vertical milling machine. In theory, you could even go on the lathe if there's enough to hang on to. So there's multiple ways to do that. I'll leave that up to you. The main goal of this was to show you how to drill holes using the UMC, kicking at angles. If you have any questions, let me know, and hopefully this was interesting. Thanks for watching.